So get your givens down. Good call. Good call. Alrighty, well, there is a vocabulary term that jumps out, right? Bisects. So some of you guys might be on the mindset right now, little halves of equal quantities action, right? Well, let me squash your dreams and hopes. How many angles are being bisected?
One.
How many?
One.
Halves of equal quantities, you need how many?
Two.
And they have to be equal. I don't think so. Not on this one. Does everyone see why? Even though it says bisects, I got to bisect two angles that have to be equal. So if I'm not going to do that, how can I still use bisects in this proof? Because remember, I give it to you for a reason. Use it. There's a reason why I give you bisects. It's not halves of equal quantities. It's to show something else is true. So if you know EC bisects ADB, instead of telling me half of something, what can you tell me is true? Dylan, go.
ADE is congruent to EBB.
Yes, and bisector cuts something in half, but it also cuts it into two congruent angles. So that's the fact I want. Angle ADE is congruent to angle EDB. Definition of a bisector. All right, well, if I look at the proof statement, I'm supposed to prove ADE congruent to FDC, and I already have ADE in there, right? I already have ADE in there, so I'm going. Maybe, hopefully, I can say something about FDC sooner or later. Before we do that, though, let me talk about the other given, the one that doesn't say bisects, the intersect one. I talked to you on Friday about this. Everything's given for a reason. So why in the world would they give us that two lines intersect? What did we talk on Friday? If two lines intersect, what type of angles are formed? Darn right, vertical. Anybody see any verts in here that maybe that would help us out? Or maybe would involve the other angle I have not mentioned yet, FDC, that's in my proof statement. Do we see any? Nope, I'm going to do it without Brody. Got it.
Angle EDB and angle FDC are congruent.
There you go. Everyone look at EDB and FDC. Those are the two opposite angles formed by those intersecting lines in the givens. Vertical angles are congruent. You do not need to tell me they're vertical angles. Just say they're congruent. So I got two angles that are equal because of the bisector, and I got two angles that are equal because they're vertical. How can I pull this all together? Don't go back. There's nothing else the diagram can help you with. You got to go back to what you just wrote down. Look at steps 2 and 3, what you just wrote down. The diagram's not going to help you anymore. Look at steps 2 and 3. You see anything? See anything? Two angles that are both equal to the same one. So those other two have to be congruent to each other. And look at that. It just happens to be our proof statement. ADE congruent to FDC. And what's this called? Substitution. There you go. Questions? Here's the rule today. You don't move. You can work with people in your group, but you don't move to other groups, or you can work individually. But before you move on to the next proof, I need to approve the current one to make sure it's correct. So just raise your hand individually or in a group. I don't care how you do it. Just raise your hand. You need to take a look at my proof, and then you don't go on to the next one until I give you the okay, because I got to make sure you guys are doing these correctly. All right, do your thing, either in a group or individually, but I got to see it before you go on to the next one.
Yeah. So